Well, hello there, everybody. I'm back. Yeah, we're back at it. Shout out to Saki Norris and also to 1 2, the girls of 1 2. Big shout out. So today I'm going to do area and volume from the Irish curriculum and also from the iGCSE, which is like an international version of the English curriculum. The Irish curriculum, I'm going to do the junior cert, which you do in like your third year of secondary school, and I'm going to do ordinary level, so it's not higher level. I'm going to do the same topic then for iGCSE, which you usually do in like your fifth year of secondary school. So there is a bit of a difference there, and yeah, I'm doing like the standard level, so it's not ordinary level. So there might be a difference there in terms of difficulty, but I would say most of the material is transferable. Similar topic, same topic, in fact, similar questions, just maybe slightly more difficult since you're doing it in your fifth year. But anyway, let's go. Here we go. So junior cert area and volume. All right, cool. So here are a couple of questions. We'll start here and we'll rock and roll. So you're given this cylinder. You have to pretend that this yogurt carton is an actual right-angled cylinder. Anyway, Martina buys a carton of yogurt. The yogurt is roughly in the shape of a cylinder. It has the dimensions shown in the diagram below. Great. Work out the volume of the carton in centimeters cubed. So we have to work out the volume in centimeters cubed and then give your answer in terms of pi. So they want the answer in terms of pi. All right, so let's proceed. We have our formula down here, which is nice. It's right here. So there's our formula. We just substitute. So we know what pi is. R equals what? Well, you can see R up here is 4 centimeters. So R is 4 centimeters. H here is 11 centimeters. Cool. And we just stick them into our formula. So we're going to say V equals volume equals pi R squared H. So I'm just going to rewrite the formula. And that equals pi. R is 4. And we're going to square that. And H is 11. Now they want their answer in terms of pi. So that means you don't multiply pi into it. You just leave it at the outside. So when you do that on your calculator, you should get, what am I saying? 4 squared is 16. 16 times 11 is 176 pi. And then centimeters cubed, don't forget that. Centimeters cubed. And that's it. That is it. Nothing to it. Ain't nothing to it but to do it. And that's that done. We move on. The carton contains fruit and yogurt and weighs 450 grams. The ratio of fruit to yogurt is 4 to 21. Work out how many grams of fruit are in the carton. All right. So you can see here straight off, we have that. The ratio is 4 to 21 and it's 450 grams. So fruit to yogurt. So fruit to yogurt. Yogurt. All right. If you're from America, you don't have a T or an H here. So we know that that is 4 to 1. So basically, we have a total of, so it's 4 parts yogurt to 21 parts, 4 parts fruit to 21 parts yogurt. So that's 25 parts. Maybe some of your teachers might call it shares, 25 shares, but it's 25 parts, right? So we've 25 parts, 4 of them are fruit and 21 are yogurt. So we have 450 grams. So we know 25 parts. Let's just put parts here. I know it's a bit weird. 25 parts equals 450 grams. So we were told that. So then 1 part, well, what would 1 part be? Well, 1 part would be, how do you get from 25 to 1? You divide by 25. So we do the same over here. So 1 part would be 450 divided by 25. All right, I'll even write that down. 450 over 25. You don't need to write that down. You could just go to a straight line, or the next line, straight to the next line. So you could go 1 part equals, and you just do that on your calculator. What should it be? 18 grams. So 1 part is 18 grams. Now you have 4 parts yogurt, or 4 parts fruit, excuse me, and 21 parts yogurt. So 4 parts, well, 4 parts equals, well, how would you get from 1 part to 4? You multiply by 4. So you do the same over here. So you're going to do 18 times 4, which is 72 grams. All right. And then we want, that was it. We only wanted how many grams of fruit? Okay, so that's your fruit. Fruit is 4. And while I'm at it, I'll just do the yogurt, just in case you're wondering. Yogurt. So it's 21 parts. Okay. So you just multiply 1 by 21 to get that. So multiply 18 by 21 to get this. Or you could just subtract 72 from 450. Exactly the same thing. And your answer will be 378 grams. So just in case you're wondering how did he do that? So we know 1 part is 18 grams. So to get 4 parts, we just multiply 18. I'll just write it here. So 18 times 4. Right, to get 4 parts. And to get 21 parts, it's going to be 18 times 21. 18 times 21. That's how we got that. All right. So once you get to 1 part, I'll just highlight it. Once you get to 1 part, that opens the key to everything, basically. Coolio. We'll move on to the next page, which is here. So Clive. Hope there's nobody called Clive out there or related to someone. It's not the most interesting name. Can I say that? Maybe not. Sorry, Clive, and all people related to Clive. Clive estimates the dimensions of a rectangular tank to be 5 meters by 4 meters by 3 meters. Use Clive's values to work out the volume of the tank. Okay, straightforward. So the volume is just the length times the width times the height. So volume, so I don't know, length times width times the height. Or sometimes they say length times the breadth times the height, or sometimes they say length times the depth by the height. It doesn't matter. It's just the 3 different dimensions. That's all you got to do. The 3 different dimensions multiply by each other. And that equals, it literally, you could call that the length, you could call that the length, you could call that, it doesn't matter. Anyway, it's 3 times 4 times 5. Now 3 times 4 is 12. 12 times 5 is 60. So you're going to get 60, and the units are meters squared. Whoa, that's wrong, isn't it? That is wrong in the question. The volume is meters cubed because it's 3 dimensions. So there you go. That should be meters cubed. Anyone that spotted that? Well done. So that would be your answer, 60 meters cubed. Clive's estimates are all correct to the nearest meter. Now this where it gets a bit tricky. The actual volume is k meters squared. So you might see k, like what is that? Don't worry, it's just a number. It just means we don't know what the volume is, right? It's a natural number. So that means it's a counting number, which means it's a whole number that's not 0. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some whole positive, it's a positive integer that's not 0. So it's a counting number. It's going to be a whole number. That's all. That's all you need to know. So work out the largest value the k could have. Okay, so you might be like, what are they talking about here? So the clue is Clive's estimates are all correct to the nearest meter. So we're told here Clive estimates the dimension. So these are not the exact actual measurements as far, they're probably not the exact measurements. So they were estimates and they were to the nearest meter, okay? So we have to work out the maximum volume. Okay, so if these are to the nearest meter, let's write it down. So let's say the length of sugar, sorry. So if we said the length equals, that's a terrible L. The length equals whatever, 3 meters. 3 meters. And the width we said was 4 meters. And the height was 5 meters, whatever. H equals 5 meters. Now they're all to the nearest meter. Okay? That's the nearest meter. So if that's rounded, that has been rounded to the nearest meter. So you have to find the upper bound of that, okay? So the upper bound, so this is to do with bounds. All right? So what we're going to do is we're going to come in here and just write the upper bound. Upper bound. Upper bound. So if this is an estimate to the nearest meter. So what you do is you get the degree of accuracy, which is the nearest meter. That's your degree of accuracy. Now, you mightn't have heard your teacher say that, but I'm just going to say it because that's how I understand it. Right, accuracy. That's your degree of accuracy. So basically, you half that, and then you add it on to get the upper bound, and you deduct it to get the lower bound. Okay, but we're looking for the upper bound because we're looking for the largest, so the biggest value. So the upper bound, degree of accuracy is nearest meter. So what's half of a meter? Is 0.5. So half gives us half the degree of accuracy is 0.5 meters. Okay? So half of this gives us 0.5 because that's the nearest meter, which is 1 meter. And half of that is 0.5. So the upper bound is going to be 3.5 meters. The lower bound is going to be 4.5 meters. Or sorry, the upper bound of length is 3.5. The upper bound of width is 4.5. And the upper bound of the height is 5.5. So they are the maximum possible values that the length, the width, and the height could have. So obviously when Clive measures them, he can't measure them exactly. So these are the measurements that he gets. But this is the actual, if he had an accurate enough way of measuring them, this is the maximum possible value that it could be. Now, you could say with the lower bound, it could actually be less than this. We don't know. But anyway, this is the maximum it could be. Right, enough talking. So this all you have to do. The volume, the largest volume, what I call it large, put a subscript large. The largest volume is 3.5 times 4.5 times 5.5. All right, so you just throw that into your calculator and you'll get an answer of 3.5 times 4.5 times 5.5. So you should get something like 86.625. Wow, that's quite a big difference from 60. So that equals 86.625 meters cubed. Now, we're told it has to be a whole number because Ken, not Barbie and Ken, it just means K is an element of the set of natural numbers. So it has to be a whole number. Well, it can't be 87 because we're told this is the absolute maximum that it can be. So the nearest whole number that this could be is 86. So we can put a little wavy equals, approximately equal to 86 meters squared. And that is it. So whatever. You could say K equals 86, basically. That's, sorry, that should be cubed. All right, and that's it. So K is 86. So, okay, a little bit tricky there. A little bit tricky. Tough question. But we got it. All right. Coolio. So let's move to iGCSE. This can also be useful for the junior cert higher level and ordinary level. So let's look at this. Here we go. A cylinder has a radius of 5.4 centimeters and a height of 16. Cool. Work out the volume of the cylinder. Okay, this is easy peasy. So your formula for the volume is V equals pi r squared h. Why is it pi r squared h? Well, if we, could I do this? I'll probably butcher it. No, I'm actually doing all right. You see that circle at the bottom of the cylinder, the base of the cylinder. What's the area of the circle, of any circle? It's pi r, well, any circle on a flat plane. It's pi r squared, right? It's pi r squared. So you know that's pi r squared, and then we're going to raise that by a height. We're going to drag that all the way up to here, yeah? So you kind of get that circle and you drag it up to here. So this is pi r squared. And you're dragging it up that height. So just imagine drag it all the way up. Maybe I could just grab it. Yeah, and then we're dragging that all the way up there. So that's why it's pi r squared h, all right? Anyway, let's get on with it. So volume is pi, r is 5.4. So it's the very same as the junior cert ordinary level question, to be honest. H, except the number is a little bit different. Work out the volume. Now they want to correct to the nearest whole number. So do not give these people who are marking it the pleasure of taking marks off you. All right. So they want to the nearest whole number. So let's do that. So just throw that into the calculator. This time we will multiply the pi because they want to the nearest whole number. So you're going to multiply the pi, and I get 1465.741. So I'm just going to go, sugar, what did I do? 1465.741 ... right? And we throw out the nearest whole number, so it's approximately equal to, well, where's the whole number place value? It's here. Look to the right, it's 7, so that's going to round up. So it's 1466 centimeters cubic, also known as cubed, and that's your answer. That is it. Boom. Nip, clip, kaboom, as they say. Right, so that's it. So I'll just waste time moving this down. And yeah. What am I doing here? I'm too nitpicky about this, aren't I? I'll just move all this stuff down. There you go. All right, come on, 3. You're coming down. And that's it. And there's not much else to that. Cool. Right. So that's that. Let's go down. The radius 5.4 is correct to 2 significant figures. Write the upper bound of the radius. So this is very similar to the junior cert ordinary level, which you do 2 years earlier than the iGCSE, and it's the ordinary level. So, you know, the Irish exams are quite good when you think about it. The radius is, okay, correct to 2 significant figures. So let's do that again. So R, just similar to what we did last time, radius is 5.4 centimeters. Now, upper bound. So we have to find the upper bound again. So we're told it's correct to 2 significant figures. Okay, well, where is the second significant figure? It's here, it's the 4, right? So to get the upper bound, you remember, as I said before, we have to half the degree of accuracy. So the second significant figure is here. So we're going to have half the degree of accuracy. Probably switch. So here is 0.1. We half that, you get 0.05. Anyway. You're probably like, what? That's quite confusing. All you do to get the upper bound is you stick a 5 at the end, right? That's it. Now to get the lower bound, you also, right, I'm going to rewrite it. You also stick a 5 at the end, but you reduce the previous number by 1. That will give you the lower bound. So it's a little trick there. So let's do that. So to get the upper bound, we just write that down, 5.4, and we stick a 5 at the end. Cool. And that's it. Now that won't always work, but here it will. All right, 2 significant figure. So what I would do, you go to the 3rd significant figure and you put a 5. That's it. So it's 5.45 centimeters. That is the maximum possible true measurement of the radius. Write down the lower bound of the radius. Yeah, so you just do the exact same thing, just like I told you there a second ago. We can actually just copy all of this down, can't we? If it lets us. So I'm just going to copy this whole stuff down. It's not letting me for some reason. Okay. I'll just rewrite it. R equals 5.4 centimeters. And lower bound. So lower bound, as I said, just rewrite it. 5. We're going to reduce this by 1 down to 3, and we just stick a 5 at the end. And that's it. And that's your lower bound. Cool. So the whole thing was this, all right? Now, as I said, that might not always work, but it does work for this. Right. So if it was me, right, technically the second significant figure here is that 4, right? That's the second significant. So the place value of that is 0.1. That's the place value. So we have 4 of these, right? Or you could say, if you want, that's a 10th. So we have 4 tenths. So remember what I said before, you half that. So half of this will give you 0.05. So you just add that on to get this. But yeah, it's superfluous here. You don't really need it. But that's just another way of thinking about it. I don't want to confuse you too much, and I probably have. Whatever, I'll just put it in a different color there. Fine, anyway, that's it. So you just stick them in the answer area. Okay, here's a prism. Great. So we're told it's a prism, we can see that. ABCDEF is a cross section of the prism, yes. And then ABC, that's a square, we're told. And this is a trapezium. All right, great. So we're told that's a trapezium. And then this other thing up here is a square. So I'll just mark them in just so you can see what's going on. So this is a square, and that's important because that allows us to get some information. I'll just color it in, and cool. And then I'll color this one in. So let's proceed. There we go. Well, let's look at this. Let's fill in what we know. So we're told this is a square of side 12. So that's 12. That's 12. That's 12. Cool. ED is 22. Yes. All right. The height of the prism is 20 centimeters. Great. Now let's use that straight off the bat. All right. So we're told that's a square. Done. Now the height of the prism is 20 centimeters. So let's use that information. That's 20. Well, if AF is 12 and AE is 20, or sorry, A to the bottom is 20, what's this height going to be? This vertical height here, what is that going to be? Well, it's going to be 8, isn't it? Because that's 12 and that's 20. So that's going to be 8 centimeters. And that will help us. The length of the prism is 80. Great. Find the volume. So the volume of the prism. So prism volume is, remember, it's the area of the cross section. Area or cross-sectional area of cross-section CS times the length. Quite simple. Okay, so 1, what is the area of the cross-section? So area of square. Let's get the area of the square. What's the area of the square? It's 12 times 12. 12 times 12, which is 144. I'm not going to bother putting in units right now. To area of trapezium. So the area of the trapezium right, there's my colons. The area of the trapezium. Now you could split this up, but there is a formula for the area of a trapezium. It's half the sum of the parallel sides. So that is parallel to that, clearly. So it's half the sum of the parallel sides multiplied by the height. So it's A plus B over 2 times H. And you can put that in brackets if you like. So A and B are the parallel sides. So that equals 12 plus 22 over 2 over 2. And we're going to multiply that by the height, which we figured out was 8. All right. So, well, 22 plus 20, or 12 is 34, divided by 2 is 17. So 17 times 8 is 136, I believe. So it's going to be 136 centimeters squared. All right. Well, I might as well put centimeters squared here then for the area of the square as well. So that's it. So I'll tidy this up slightly because it's a bit congested. A little bit congested. And on group. So I'll just move that up here. All right, fine. There we go. So we know the area of the trapezium is 136 centimeters squared, and we know that the area of the square is 144 centimeters squared. So strangely, the area of this square is bigger than it, even though it doesn't look it. Yeah, because this 8 is obviously stretched. So this is not to scale, and it says it there. Look, it even says it there. It's not to scale, and that makes sense because that trapezium looks way bigger than the square. Anyway, that's it. So let's do it. So let's go back to our original formula, which is the prism volume. So it's the area of the cross section times the length. So the area of the cross section, let's do it. Prism volume equals area of the cross section. So that's going to be, well, let's put it in here actually. 144 plus 136. Yeah, that's the area of the cross section. Do you want me to do that separately? I'll actually do it separately, just so I have it. Area of CS of cross section equals 144 plus 136, which is 280. All right, I'll just put it in here. 144 plus 136, which equals 280 centimeters squared. And then the volume of the prism, equals area of the cross section times length, 280 times, what was it, 15 or something? 80. Oh, geez. 80. All right, that equals, what's that? 36. Is it 56 times 4? 224? 2240? Something like that. Let's do it. 80 times 280 equals, yeah, 22400. 22400. And its volume, so it's cubed, and the units are centimeters, so centimeters cubed. And that is it. Centimeters cubed. Coolio. That's it. So again, like they were saying, the volume of this shape is that cross-sectional area, and you're just dragging, oh sorry, you're just dragging that through the whole shape till it gets to the other side. So you're multiplying it by that 80 there, all right? And that makes sense. That's it. Will I do another one? That's a cone, by the way, just in case you don't know. The mathematical shape of this, or name of this shape. So you could say it's a triangular prism, or you could say it's a right angle triangular prism, or a right triangular prism. All right. How many edges does this shape have? Please don't get that wrong. Please don't get that wrong. Edges: 1, 2, 3, 4, 5. Count them: 6, 7, 8, 9. It has 9 edges. 4 on the bottom. 5, 6, 7, 8, 9. It has 9 edges. So don't get those wrong. How many vertices? Vertices are just corners. 1, 2. Count them: 3, 4, 5, 6. How many students get these wrong? Even the supposedly smart students get wrong. 6. Cuboid. The volume is 280. It has a length of 80 and a width of 4. All right, this is straightforward. You're told the volume, which equals length by width by height, equals 280. Well, you're told that the length is 10 and the width is 4. So 10 times 4 times h equals 280. So that implies 40h equals 280. So then that h has to be 280 divided by 40, which is 7. H is 7. That's it. There are more, but there are more here. Let me know if you want me to do them. But I'm going to knock it on the head for now. Annyeong higeseo. I'm out of here.